Let us learn about Michelson Morley experiment in this particular class. A hypothetical medium ether exists everywhere, even in vacuum. This is according to Huygens wave theory. So we are talking about the past. Okay, physics in the 1890s. We are talking about physics in the 1890s. In the 1890s, physics was not much developed. Physics was not much developed in the 1890s, and the result was that in those days it was considered that whatever wave is there, waves need a medium. It was assumed that all kind of waves need a medium to travel. It was assumed like that in those days, in the 1890s. Okay. Now, because of that assumption, people questioned that if you are saying that all the waves require medium for traveling, then how does sunlight reach the earth? Because between sun and earth, vacuum exists, space exists. So how are light waves coming from sun to the earth? If waves require medium to travel, then how light from the sun reaches the earth? If waves require medium to travel, then light is a wave, and how light is traveling in the vacuum then? So Huygens told in those days in 1890s that even in vacuum ether exists. Okay. So as ether exists even in vacuum, it is a hypothetical medium. Okay, means they used to think that this medium exists. So ether exists everywhere, even in vacuum, according to Huygens wave theory. He had given this particular ether hypothesis because he wanted to tell that light waves reach from the sun to the earth. So how do they reach from the sun to the earth? Because there is no medium. So waves require medium for traveling. Then how is light reaching the earth? So he said that ether exists everywhere, even in vacuum. Okay, so he said like that. Although he was proved wrong later on he was proved wrong. But at that particular time he said like that. Okay. So light waves are vibrations of ether particles. This is what is according to Huygens wave theory. That light waves are vibrations of ether particles. At that time, scientists did not know that light does not require medium to travel. Okay. At that particular time, scientists did not know that light does not require any medium to travel. Light can travel through the space as well, through vacuum as well. Light can travel through the vacuum as well. This particular fact scientists did not know. And why the scientists did not know this particular fact at that time? Because scientists used to think that light is a wave, and wave requires material to travel. Okay, so light or travels through ether. So there is material called as ether present everywhere, even in vacuum, and because of the vibration of those ether particles, light waves are propagated. So velocity of wave motion is given by, so if light are waves, then the velocity of light will be given as a square root of E by rho. Okay, where E is the elasticity and rho is the density. So light waves are vibration of ether particles. So velocity of light wave will be given by V is equal to square root of E by rho. And what is capital E over here? Capital E is the elasticity over here. And what is rho over here? Rho is the density over here. Okay. So density of the medium is rho and elasticity of the ether. Elasticity of ether is E and density of ether is rho. Okay. And ether is that it means that light was being considered like a mechanical wave. The way sound requires material to travel, right? Sound waves cannot travel through vacuum. You must be knowing this particular fact that sound waves do not require sound waves require medium to travel. Sound waves require medium to travel, whereas light waves do not require any medium to travel. This fact you know nowadays. But in those days, light waves were considered like sound waves, which are requiring a medium to travel. In those days, it was thought like that. Okay. Now, according to this particular equation, it was already known that the speed of light is 3 into 10 to the power 8 meter per second. It was already known at that time that the speed of light is 3 into 10 to the power 8 meter per second. Okay, that is equal to V. So E by rho should be equal to what? E by rho should be equal to 9 into 10 to the power 16. Okay, 9 into 10 to the power 16. Why? Because V is equal to square root of E by rho and V is equal to 3 into 10 to the power 8. And if you take square on both the sides, so E by rho will be 9 into 10 to the power 16. Okay. Now, you know this very well that if such a huge is the ratio, then density should be low and elasticity should be high. Right? Because if you lower the denominator, the quantity increases. Okay. If you lower the denominator, the quantity increases. and if you increase the numerator, the quantity increases. If you lower the denominator, the quantity increases, and if you increase the numerator, the quantity increases. Okay, this is the thing. But for such a huge ratio, if we say that rho is very low and elasticity is very high, then such a combination is not possible, because you know this very well that as density of a material increases, its elasticity also increases. Okay, because more dense medium are more elastic. Okay, so density when it increases, elasticity also increases. So if we say that elasticity is very high and density is very low, in order to get that 9 into 10 to the power 16, so it is contradicting. What it is contradicting? It is contradicting that rho is low and elasticity is high. Okay, but if we still consider this to be true, then what will happen? Rho should be high, because only then the elasticity will be high. So if rho is high, then E should be even more higher. E should be even more higher in order to maintain this particular ratio. Okay. So if we consider rho is higher, then elasticity should be even higher. Okay. In order to maintain 9 into 10 to the power 16 ratio. In order to maintain 9 into 10 to the power 16 ratio, we can say like that. But if we say that the density is very high, then will the medium even remain vacuum? The If you say that density is high, then it is contradicting the fact that it is traveling in vacuum, because if rho means if density is high, then there is material present, obviously. So if material is present, how can vacuum be present at the same time? Okay, so this was the problem which was arising. Okay, and this all problem arose because they considered light to be a mechanical wave, just like sound wave. Okay, they considered like that. That is why this problem arose. So this particular equation V is equal to square root of E by rho, this particular equation doesn't justify V is equal to 3 into 10 to the power 8 meter per second. This particular equation V is equal to square root of E by rho, this particular equation V is equal to square root of V by rho doesn't justify V equal to 3 into 10 to the power 8 meter per second for light. And this is precisely the reason existence of ether was doubtful. This is precisely the reason why existence of ether was doubtful. Okay, so aim of this Michelson Morley experiment was to determine whether ether exists or not. This Michelson Morley experiment wanted to determine whether ether exists or not. So aim of the experiment is that to detect relative motion between the earth and the ether. Okay, if ether exists, it was assumed that ether is always at rest. Okay, this is a very important assumption at that time. Ether was assumed to be always at rest. Okay, always at rest. It is never in motion. Okay, it just vibrates when light travels through ether. Ether vibrates, but ether always remains at rest. Okay, it is not moving. This is the thing. Okay, now the aim of this Michelson Morley experiment was to detect the relative motion between the earth and the ether. To detect the relative motion between the earth and the ether, as earth is rotating on its axis. Earth is rotating on its axis, and you are saying that ether is present everywhere. You are saying that ether is present everywhere, even in vacuum, and even everywhere ether is present, even in vacuum, and even at those places where medium is present, there also ether is present, you are saying. Okay, so there must be a relative motion between earth and ether, because earth is rotating on its axis. Okay, and ether is always assumed to be at rest, so there should be relative motion between earth and ether, because earth is rotating on its axis and ether is always at rest. So ether should drag. When earth is rotating, ether should drag. So to detect the relative motion between the earth and the ether was the aim of this experiment. Okay, and another aim, or we can also say it like this, to locate a preferred frame of reference. During those days, ether was considered to be a preferred frame of reference. Why was ether considered to be a preferred frame of reference in those days? Because ether was always considered to be at rest. According to Huygens wave theory, ether is always at rest. So preferred frame of reference will be ether, because ether will be inertial frame, it is at rest. Okay, so ether will be inertial frame, and it is called as preferred frame of reference, because everything we measured with respect to ether will be the true value, because ether is at rest, so it is a preferred frame of reference. So the aim of this Michelson Morley experiment was to detect the relative motion between the earth and the ether, or to locate a preferred frame of reference. Okay, you can write both. Okay, so and also you can also write to test the, you can also write over here to test the existence of ether. Okay, you can also write to test the existence of ether. This Michelson Morley experiment was performed. So introduction of the experiment and aim of the experiment, you are clear with this particular thing, that introduction, why was the Michelson Morley experiment required, okay, and what was the aim of the Michelson Morley experiment, you have already studied in today's class. In the next class I will tell you regarding the experimental setup of Michelson Morley experiment. What was the experimental setup, from there onwards we will learn in the next class. Okay, thank you very much.